All right, number 10. I know, it's cool, huh? Fancy. Okay. So this question says, a base runner who is running at a rate of 25 feet per second is halfway to first base. Find the rate of change of his distance from second base. So luckily they gave us a picture on this one, because for some reason this is why I don't teach geometry. I have a really hard time picturing stuff. Like, I have to draw it every time. Even when I'm gonna like rearrange my room, but then, yeah.
Like even the picture.
I forgot what plane the space.
That's why they gave it to you. They would never, on an AP test, they would never expect you to know something like, oh, the bases are 90 feet away. Like, they will give you information that you need like that. Okay, so here's our picture. He starts here, and he's halfway to first base, so he's right here.
45 feet.
And we want to figure out how far he is, find the rate of change of his distance to second base. So first thing first, let's, we drew our picture. Let's figure out our variables and our constants. Let's name this. Let's name that. Do you want X, Y, and Z, or do you want A, B, and C?
A, B, and C.
Is A, B, and C a little better since that's how you learned the Pythagorean theorem? Okay, we'll call it A, B, and C. Sorry for those of you who wrote X, Y, and Z already. A, B, and C. Okay.
I used B, H, and D, so I don't think it's a problem.
That's okay. So we have to decide what is changing and what is not changing. Is A changing?
No.
Yes. Our freeze moment tells us when it is, but A is changing because he's running, right? Is B changing?
Yeah, no. Wait. No. Well, and wait afterwards.
No, because it's 90 feet.
No, it's not. B is not going to change because it's always that, because this triangle disappears when he gets to here.
B stays the same because
I agree. So our variables are A and C. Our constants are B.
What is the
constant?
B is constant at 90. So B always equals 90.
Okay.
Okay. And then we've got, let's talk about our rates of change. Are any of our rates of change constant?
25. All of them are, except for the C.
Yeah, so 25, he's running at a rate of change of 25 feet per second. So our dA dt, yep. So dA dt is also constant at 25.
DB.
dB, there is no change because the change of B is 0 because it's not changing.
So when you do the derivative, it's 0, right?
So because it's not changing, we put B in as a number instead of as a variable. I'll show you. Okay, I feel like I need another.
Are we finding dB?
Yes, find the rate of change. Okay, so it asks us to find dC dt. And then we have to look at our freeze moment. We freeze it when he is halfway to first base. So freeze when A equals 45, right? Because it's halfway.
I missed that constant.
Yeah.
Was that in the video?
The constant thing? Yeah.
Yeah.
Yeah. So I talked about
What was the freeze again?
25. I was going to pull up this graphic organizer that we had so that. Yeah. So if it's a constant, remember that we don't. The derivative of a constant is 0. So what is dB dt? It's 0. Okay. So we ended up with this triangle like this. This is A, B, and C, and B is 90, so we can just put 90 in there because it's always there. So our variables were A and B, not B, A and C, and dC dt is changing, right? Our constants are B, which is 90, and dA dt, which is 25. Okay, our freeze moment is when A equals 45. So let's relate these equations. Remember, we write an equation that relates the things that are changing. So we need to relate A and C to each other, because those are the things that are changing. So since this is a right triangle, we know what that is, right? A squared plus B squared equals C squared. And anything that is constant, we can just plug in right now. But we cannot plug in our freeze moment right now. We can only plug in our constants right now. So B is constant, so we can just put that in. What's 8100? 90 squared? I almost asked that. That was an easy question. Sorry. Okay. Now we find the rate of change using the derivative. So this is going to be 2a dA dt plus 0, because the rate of change of that is 0, equals 2c dc dt. And since we're trying to find dc dt, we plug in everything else and solve. This is our solution part. So we know that A is 45. We know dA dt, don't we? 25. Perfect. I don't know why I wrote that small. That's 25. Plus 0 equals, and then 2c dc dt. So here's our problem. We just don't know c. Can. We can. At our freeze moment, we know A is 45, and we need what our C is at that freeze moment, right? So we have 45 squared plus 8100, which is B squared, equals C squared. So don't make me do that in my head. What's that on the calculator?
That answer is like 100.6. Yeah.
45 is 2125.
What is it?
2025.
2025 plus 8100. Okay. So C is what?
1,000.
Okay, and then take the square root of that for me, and we'll get C.
100.62.
100.623. So if this is not a
I
final,
just left it.
yes, if you're not at a final answer, don't round it, just keep it in your calculator. In fact, you can use the store button if you need to. So at the bottom of your calculators, there's that store. You can store it and then store it as like A or B or C. So you can use it later. Have you guys done that before?
Yeah, you taught us during COVID.
Oh, I did, yeah. So you go down to store and then you push alpha and pick whatever letter you want. It's right above the on button. It's STO. STO with an arrow. Yes, no? Let me pull my calculator up here. Okay. Nope. Okay, so if I did 2025 plus 8100, then I like what Malachi was saying. He just left it as a square root. But, so you could have just put in the square root of 10. So if I have this, then I push store, which is right here. And then I do alpha and then pick a letter. So I'm going to call that A. So now every time I put in A, it's going to bring out that number, the whole thing, because it only shows me these decimals, but it has a whole bunch more decimals that are in the wings, right? So then it will use those. Okay, so then our last step is we need to multiply, or we need to divide by 2c, right? And c was the square root of 10, 125? Yeah. I'm going to divide by that on both sides. Those 2's are going to go away. All right, so we got 45 times 25. And then if I want to divide by that number I already have in my calculator, I can just go divided by A. It's going to give me 11.180. Now remember, in calculus, we always go to 3 decimal places, even if that 3rd decimal place is a 0. So you still write the 0.
I think, because I remember doing that last night.
Is that the right answer?
Oh, yeah.
It is, but it's
But it's
negative.
negative, yeah.
Right. Okay. So this is where your powers of deduction have to come in. It's saying, find the rate of change of his distance from first base. So is he getting, he's running at a rate of 25 feet per second. Actually, I think we should have had our 20, no, because that's positive. Trying to think of whether we should have done the 25 negative. Or if we just realize that he's getting closer and closer to first base as he's going further. And you just have to know that it's negative.
It's the second.
Or second base. Yeah, he's getting closer and closer to second base. He's running at a rate. Oh, yeah, his 25 needs to be negative because how is A changing? A is getting smaller by 25 feet every second, right? So it says he's running at a rate of 25 feet per second. So we have dA dt. dA dt, how much is A changing every second? It's getting smaller and smaller every second, right? It starts at 90 and it's losing 25 feet every second. So we should have, I should have caught that. And I remember that's why we were doing this one now. That should be negative 25. So then that makes everything negative down here. Does that make sense why that's a negative 25?
Yeah.
Because it's going smaller. Okay. All right. Are there any others on 6?